2/3 of all miles we drive in the United States are on roads with traffic signals. According to the Institute of Transportation Engineers, we have about 300,000 traffic signals in the U.S. Over 75% of these signals could easily be improved by updating equipment or by simply adjusting the timing. Traffic signal management is one of the most cost-effective ways to help traffic move and make our streets safer. So what is traffic signal management? It's taking the existing traffic signal equipment already in place and using available tools, techniques, and in some cases, improved equipment to more efficiently utilize our city streets and signal systems. Traffic signal management can have several benefits when put in place. Better management of traffic signals can help improve air quality and reduce fuel consumption. Traffic signal management reduces congestion, saves time for commercial vehicles, emergency vehicles, buses, and the public. Traffic signal management reduces the number of severe accidents on city streets by producing smoother traffic flow with fewer stops. This can also reduce aggressive driving behavior by minimizing the running of red lights, making our intersections safer for motorists and pedestrians. Traffic signal management can also postpone or eliminate the need for construction of additional capacity.
We've priced out a section of Wadsworth to widen it from 4 lanes to 6 lanes, and it would be $37 million. We recently did a retiming plan in that section of Wadsworth and got a 12% reduction in travel times for a mere fraction of the cost.
Is that over 1/3 of those intersections could have significant improvement in reducing travel delay and so forth with what we call low-cost improvements, less than a few $1,000s, either restriping or more likely just retiming the signals.
And that's just adding efficiency. That's something we can do to make people's lives better today. And I think every mayor, every administrator wants to do something about that.
Let's look at other traffic signal management programs that have been implemented and the effects seen in real-world situations. First, a statewide traffic signal retiming program in California produced a 7% reduction in overall travel time, a 15% reduction in delay, and had a 9% saving in fuel usage, all while achieving an outstanding benefit-cost ratio of 58:1. Similarly, in Abilene, Texas, a small-sized urban area, by putting in a new signal system and improving signal timing, a 13% reduction in travel time, a 37% reduction in delay, and a 6% saving in fuel usage was achieved.
And it's working. We are added 22% efficiency on Aurora, one of our major arterials, 16 to 18% on another, and 26% on another one, better than the 5 to 15% increase in capacity that we thought we would achieve.
Benefits in vehicle delay in the hundreds of thousands of hours per year. Benefits in fuel consumption, obviously, that go with that, air quality improvements, and so forth. Appreciated benefits are those that allow the pedestrians to cross the street, allow the side streets traffic to get out, and just producing a more pleasant environment. Those can't be quantified as easily as the vehicle hours, but are equally as important to the community.
Typically, a signal system, we're talking in the $2, $3, $4 million range for a citywide improvement to traffic signal systems, and you can get reductions in travel time of 5%, 10%, and even more.
And the citizens get it. I mean, it's like a blinding flash of the obvious. Why haven't you done this a long time ago? It's using technology to our advantage.
Now let's talk about the traffic signal management techniques that you can use. Some of these techniques include removing unneeded signals. This will both improve traffic flow and reduce maintenance costs. Studying the signalized intersection to produce a new timing plan that will more efficiently use the available time. Developing and implementing additional signal timing plans to account for the changes in traffic flow for different times of the day or days of the week. Adding traffic detectors to minor side streets. Including protected turn phases can improve safety by protecting vehicles making left turns. Installing new and improved signal equipment such as solid-state electronic controllers. This can provide the additional capability to implement more advanced traffic control techniques and will improve system reliability while reducing maintenance cost. Using computer programs to design and develop proper signal timing. This will increase the chances of fully optimizing the signal timing for traffic flow conditions. Controlling signals from a central location enables someone in an office to remotely make modifications to a signal without visiting the actual intersection, both reducing cost and increasing the likelihood that needed changes will be made quickly. Coordinating signal operations across jurisdictional boundaries is an excellent way to integrate traffic flow over larger areas.
And we found that because we can coordinate among all the jurisdictions that we're getting much better traffic flow on those overloaded regional arterials. The way we did it here in the Denver area is our regional planning organization, the Denver Regional Council of Governments, took the lead in setting up a program for coordinated signal timing.
Perhaps most importantly, installing and maintaining equipment properly is key to achieving the full effect of the timing plans that are in use at each intersection. One of the most common traffic signal management techniques is to join individual signals into a system. The levels of connectivity for traffic signals range from the isolated, independently functioning signal to signals interconnected along an arterial, to larger signal systems controlled from a central office. Arterial interconnected signals can simply be individual signals timed by making the controller's internal clock synchronize with one another, or they can be linked together by wire or wireless means in a closed-loop system. There are three operating alternatives that are used in different situations. A non-actuated fixed signal only allows for set timing patterns regardless of demand. This is most applicable in high traffic areas where pedestrians are present. They tend to be best used in central business districts during business hours. An actuated signal has detectors installed in the pavement that allow the signal to detect when vehicles are present. Semi-actuated signals have detectors installed in one or more, but not all of the movements at an intersection. This type of signal is most frequently used along corridors. Generally, the side streets intersecting with a main arterial have detectors so that the signal provides green time to the major movement along the corridor and changes only when vehicles are present at the side street. Fully actuated signals, where detectors are located at every movement in the intersection, are the most flexible to changing traffic patterns. Fully actuated signals are best used in isolated areas where the effects of neighboring signals is minimal and the intersecting roads carry similar volumes of traffic. Let's discuss how you would implement signal retiming. The first step involves collecting data and documenting the traffic volumes and turns at each intersection. Next, a traffic engineer uses this data to determine new signal timing plans. He or she may rely on optimization and simulation software to accomplish this. A technician then uploads the optimized timing plan for each signal. When this new timing pattern is first programmed into the signal should be observed to make any minor adjustments that may be needed. After the new signal timing is in place, the traffic engineer and the technician document the changes and evaluate the benefits. Finally, the traffic engineer publicizes the findings from this signal retiming project. After the signal retiming project, there is a certain amount of preventive and remedial maintenance necessary to ensure the signals continue to operate properly.
It's just common sense to maximize the benefit of our existing infrastructure investment. Keep it up, manage it efficiently, as well as make new long-term investments.
So when do you need to conduct a signal retiming project? There are several changes to signalized intersections warranting the retiming of traffic signals. When a new signal is added or a signal is updated, when traffic volumes, pedestrian volumes, or turning movements change significantly, when access to a roadway changes, and when there is a change in the geometry of a roadway. As a minimum, signal retiming should be considered no less than every 3 years. However, more often is generally desirable. How many staff hours are required to conduct a signal retiming program? A signal retiming project should take around 20 to 25 staff hours per intersection. A general rule of thumb is that it will take one traffic engineer to properly operate and maintain every 75 to 100 signals, and one signal technician to operate and maintain every 40 to 50 signals. Often, consultants are used to supplement staff. How much does signal retiming cost? Traffic signal retiming costs are relatively small compared to their benefits and generally range around $500 to $3,000 per intersection. This cost varies due to the availability of existing data for the intersection and the need to collect current movement volumes for the intersection.
Well, we determined at the time the potential benefit from the retiming or restriping would be about $18,000 per year in user benefits. Our low-cost improvements, defined as signal retiming or simple restriping, we defined as capital investment of less than $2,000 or $3,000.
In summary, traffic signal system management will improve safety, economic vitality, and quality of life for most urban areas. Traffic signal retiming is also very cost-effective and can produce benefit-cost ratios as high as 40 to 1.
I think it's one of the few low-cost alternatives we have to physical reconstruction of intersection and streets.
It's a phenomenal amount of benefit in the aggregate, and every little bit helps. We're talking about higher fuel prices and non-attainment of air quality standards and so forth. It really does add up.
The money that it took to implement this program and the payback in terms of capacity and public acceptance is significant. It's the one investment we can make in the near term that will make a difference in people's lives every day.
For further information on federal highway funding and program delivery, please consult your local FHWA office located in the capital city of each state. For further technical information, visit the Arterial Operations Toolbox located on the Federal Highway Administration's Operations website.